Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject, like, share, subscribe for daily learning videos.
Problem 119 asks you, given the following assumptions, to estimate the number of atoms in the universe. So the first assumption is that all atoms are hydrogen and stars. The second is that stars are about 7 times 10 to the 8th meters in radius with a density of about 1.4 grams per centimeter cubed. C says that there are about 100 billion stars in each galaxy, using our Milky Way galaxy as an example, and that in the universe there are about 10 billion galaxies. So, the first thing that we need to recall, really from geometry class, is the volume of a sphere, and that'll come in handy later. So, planets are generally roughly spherical, and the volume of a sphere is 4/3 times pi r cubed. So that'll come in handy in a little bit. But one way that we can start here is that in order to count atoms based on information that we know here, knowing that the atoms that we're talking about are hydrogen, so we know the mass of that, and we know the density of these stars, we're converting from a mass here, grams, to a number of atoms. And the way that we do that in chemistry is using Avogadro's number, or the mole. Remember that that's 6.022 times 10 to the 23rd atoms, and that's per 1 mole. So for hydrogen here, the element that's mostly in question when we're considering how many atoms there are in the universe, 1 mole is pretty conveniently 1 gram. So we know that the density here of these stars is 1.4 grams per centimeter cubed. That's just given to us by the problem. And in order to eventually take into consideration this density as it refers to, this large star, we have to convert from centimeters to meters. So just thinking about conversions, as far as the metric system is concerned, we know that there are 100 centimeters in each meter. And then in order to get these units to cancel out, we have to cube this. So what we've done so far is we've converted basically from number of atoms per mole of hydrogen to number of atoms per gram of hydrogen using this basically the molecular weight of hydrogen, knowing that there's 1 mole of atoms per 1 gram of hydrogen atoms. We've taken the density of stars so that we can determine how many atoms essentially there are per unit of measurement of star, and eventually getting that into meters so that we can take into consideration the whole volume basically of the star using the radius. So finally, like I was saying earlier, we have to take into consideration the volume of the star so that we can count up all of the atoms in each star. So we use that 4/3 pi r cubed calculation. The radius here being 7 times 10 to the 8th meters, and then that's cubed. So that's the radius basically, or the volume per star. So now we've essentially calculated the number of atoms per star by canceling out each of these units. And then we simply have to say, or take into account that there are 100 billion stars per galaxy, or 100 times 10 to the 9th stars per galaxy. So far, that tells us how many atoms there are per galaxy. And then we know that there are 10 billion galaxies in the universe. And so, taking all of this into consideration, we finally, when doing all of this math here, get the number of atoms per universe, essentially. What this finally comes out to, once you do all of these calculations, is about 1 times 10 to the 78th stars, or sorry, atoms, specifically hydrogen atoms in the universe.